Hi everyone, welcome to the monthly Peanut Labs webinar. My name is Annie Pettit and I am the Chief Research Officer at Peanut Labs, a company that specializes in self-serve research sample. Now today's webinar will be about 25 minutes long and you can ask questions by typing them into the box on the right-hand side of your screen. You can also tweet with each other if you like using the hashtag PeanutLabsMedia. If you like today's webinar, feel free to visit our website under the resources page and you can have a look at the other webinars that we've done. So let's get started with today's webinar. Now, many of us conduct a lot of surveys. We're always concerned with making sure our data is the best quality possible. And when we see strange answers in questionnaires, we know that's a problem. But how can we tell the difference between strange answers that regular people make and strange answers that cheaters and liars make? Well, that's what we're going to look at today. I'm going to show you how to insert a few data quality measures into your existing surveys so that your survey isn't too long and respondents don't get suspicious about strange answers. Now, first of all, I am sure most people use multi-select questions. The first few set of data quality questions I'm going to talk about use multi-selects that you probably have sitting in your survey already. Now first, within that list, red herrings are a very popular data quality measure. They work well in a multi-select where people can choose as many options as they like. So if you have a list of brand names in your questionnaire, all you have to do is add 2 or more fake brands to it. So red herrings are a good method for identifying people who are trying not to be screened out because they didn't choose a specific brand name for the list. But it's very important to make sure that the fake brands are actually fake. Surprisingly, it is only after the fact that many fake names are found to be either similar to a real brand name or they actually are real brand names. You can't possibly know every local store or every mom and pop store out there. So when you create red herrings for this kind of questions, first you really do have to do a Google search to eliminate obvious real brands. Then be prepared to drop another red herring during your data analysis if you find that too many people thought it was real. Most importantly, only flag people who select 2 or more fake brands. Remember, we're seeking people who are deliberately misbehaving, not people who just accidentally made a mistake. Now, the next 2 question types go together. The high incidence measure also uses a multi-select question, and in this case, a question that is full of very common behaviors. So if you have a question where most people should have performed many of these behaviors, you can flag people who didn't choose at least several of these items. These people are probably satisficing, probably trying to get through the survey as quickly as they can to get to that reward at the end. And conversely, if you're using a multi-select with many rare behaviors, for instance, ailments or rare devices, you can flag people who choose several rare items. These people are either trying to qualify for incentives or they're reading the question carefully. So this is where you would flag people for the low incidence data quality measure. Now I've got another pair of data quality measures that apply to multi-select questions. The first one I call underclicking. So when people are satisficing, they might choose just one response instead of all of the responses that apply to them. It saves them, again, seconds of reading time, but it also means that the researcher doesn't have a full picture of what their behaviors and opinions are. So we can flag anyone who chooses only a few items from a long list when we see that most people are actually choosing quite a few items on the list. I always like to check how the entire sample has responded to these questions before I decide if 1 or 2 or 3 selects is too few. It really is different for every single question. And to match with underclicking, we've also got overclicking. These are people who choose pretty much every item in the list. Now some of them may be trying to avoid being screened out by choosing as many options as they can. In this case, we look again at everyone's responses to that question and see what an unusually high number of responses is. Maybe very few people chose more than 8 items. So in that case, we might decide that anyone who chooses 9 or more items will be flagged for overclicking. All right, another one of the things we want to make sure when people are answering surveys is that they actually read and follow the instructions we give them. Now with a multi-select, we can give people a very specific instruction such as choose 3 items from the list. Now you could have the programming team validate that the respondents did indeed choose 3 answers. But if we don't validate the question, what we can do is look at how carefully an individual has read and followed the instructions. So we can flag anyone who doesn't perform the task as instructed. So that's a following instructions data quality measure. Now another method some respondents use for satisficing is that lovely don't know option. Now good questionnaire design always includes don't know. So let's use this to our advantage. It makes sense for people to choose don't know a couple of times, but someone who chooses it every single time is clearly not taking the time to think through their answers. So all we need to do with this measure is count how many times each person uses a don't know answer, and then flag those people who use it most often. All right, the next type of question that probably appears in your surveys all the time is the famous grid question. So this is where we ask people to rate things on a scale from high to low or good to bad. Most surveys have at least one or two grids in them, so we might as well take full advantage of them while they're there. Straightlining is a very normal response among nice, regular, honest people, especially to surveys that are boring or too complicated or too long. You might also see this response from people who are just trying to finish the survey so they can get to the incentive. So, to use this measure properly, you must use both positive and negative answer options. You can't just ask if something tastes good, smells good, feels good, looks good. That's a question where people should straight line it. That's the correct answer. However, if half of your answer options are negative, for example, you've got attributes like tastes bad, smells terrible, looks weird, feels scratchy, then you really can measure straight lining. So once you're sure that all of your grid questions are properly designed to measure straight lining, then you can incorporate this technique into your data quality routine. So as before, every time you determine that straight lining has occurred, you can assign a point or a flag to the straight lining measure. Now when it comes to grid questions, you can also apply this very popular technique. You can ask people to choose a specific answer inside the grid. This, sadly, is a terrible question. We need to stop doing this now. Sure, it makes sense to researchers, but from a respondent's point of view, it is the equivalent of yelling out, "Squirrel!" It makes no sense. What am I being asked? How do I agree or disagree with that strange statement? Is it a mistake? Did the survey get typed wrong? Or even worse, are you accusing me of lying and cheating? So as a researcher, I feel this question is offensive to respondents, and I refuse to use it. Besides, we've just looked at a bunch of other question types that fit perfectly into every survey you've ever written. There is no reason to introduce a question that makes no sense to respondents. So let's just completely stop using this kind of question. The next type of question we're going to consider are open-ends. Again, you've probably got several throughout your survey, at least in the form of other, please specify. And if you're lucky, you've also already got a regular open-end verbatim question in there. So the first thing you can look at is simply verbatim length. I'm going to assume that you don't have the time to read and code every single response for validity prior to running your statistical analysis. But what you can do in the short term is look for answers that use so few characters they can't possibly have answered the questions you've asked. Now, the only reason to provide a short answer would be satisficing. So in this case, you need to make sure you've designed at least one question that ought to have a longer answer. So for example, describe 3 things you liked about the ad. What 3 things do you look for in a grocery store? What are your top 3 reasons for choosing that brand? In these cases, we know that any response that uses less than 10 characters can't possibly be answering the question. So let's create a variable to flag any verbatim answer that uses fewer than 10 characters. And along the same vein, someone could provide a lovely long answer. And in fact, I've copied these ones exactly from a survey I did. So obviously, being a long answer does not mean it is a good answer. So along with calculating the length of an answer, we're also looking for gibberish answers. Excel and SPSS will let you write syntax that looks for things like 2 commas side by side, or 2 H's side by side, or no spaces. So I set up my SPSS code to look for satisficing answers like don't know and NA, as well as quite a few profanity and crude answers or words. So I usually assign several points to the worst profanity, the F word, and such. Then I assign maybe 1 point to the gibberish variable for the nonsense verbatims. Now, do remember, it is legitimate for a good person to be so upset about a brand, a product, that they use swear words. It is not one single swear word that's the problem. The problem is a pattern of behavior across the entire survey. That's what we're really looking for here. All right, now there are a number of other types of questions that we can attach data quality measures to, so let's have a look at those. First, let's look at contradictions, which are among the trickiest measures to implement. Unless two questions are exactly the same, it can sometimes make perfect sense for people to give seemingly contradictory answers to two similar questions. So in this example, it seems as though anyone who has a pet ought to buy pet food. But what if they get the pet food for free? What if someone outside the home buys the pet food? What if they grow the pet food? We have to remember that what looks like an obvious contradiction isn't always a contradiction. So as a result, we cannot be concerned with single mistakes. We really have to build in several possible contradictions throughout your survey and then flag the set of responses that don't seem to match. Okay, so the next couple of quality measures are a little more difficult for respondents to answer, but they're still reasonable tasks. And actually, I have found them to be among my best predictors of overall data quality. The first is using rank order questions. The important feature here is that the answers should not be validated by your survey programming. Again, you can do it, but that defeats the purpose. So what we do with this measure is use an existing list of 5 to 8 items, and then we ask for those items to be ranked. Maybe on importance, maybe on frequency, maybe on how much they like it. The trick is that anyone who duplicates a number or who uses a number less than 1 or greater than 5 or 8 will get points on the rank quality measure. Then, for the sum measure, the next one, we're going to ask respondents to consider 4 to 6 items and assign numbers that add up to 100%. For those of us who are comfortable with numbers, that seems like a very easy task, but many people are not comfortable with numbers, so we have to make sure we're only using 4 to 6 items. It's a reasonable number. But once again, do not use the survey software to validate the responses. This way, we can flag anyone who isn't able to make sure their numbers add up to 100%. Now remember again, we aren't looking for people who can't do math. We are looking for people who lag behind on a number of different tasks. Okay, the last measure we'll look at, of course, is speeding. Most of the time, people want to define what a speeder is before a survey has even been launched. However, I'm going to assume that you have a final data set in hand and you are creating your own data quality measures unique to your survey. In this case, you know exactly how long every single person took answering it. You don't have to estimate an average time or a median length. So the technique I use is in 2 stages. First, I identify the fastest 5% of times. I give these people 1 point on the speeding measure. Then, I identify the fastest 2% of times, and I give these people 2 points on the speeding measure. When you get to 2%, I just can't think of any reasonable reason for you to be able to get through a survey that quickly. So, here we are. We finished the survey. We finished creating the data quality measures in the survey. Now what we're going to do is calibrate each data quality measure by itself, and then we're going to look at calibrating an overall data quality measure. So every data quality measure has a bunch of people who earned 0 or 1 or 2 points. For example, maybe people failed 1 or 2 or 3 straightlining measures, or maybe they failed 1 or 2 or 3 overclicking measures. What we need to do now is confirm a cut point for each data quality measure. What is normal and non-normal overclicking? What is normal and non-normal straightlining? What we can easily do is say that 95% of responses are normal and 5% are not. And we can automatically identify 5% of the worst scores on each measure as being not normal. So let's say the first example we see here is red herrings. 78.9% of people didn't choose any red herrings. 2.8% chose 3, 2.9% chose 2. And if we put the 2.8 and the 2.9% of people together, we've got about 5.7% of people failing the red herring question, the red herring measure. And for me, that is just about perfect. Now let's say the second scenario is for overclicking, and in this case, 76.3% of people didn't overclick any questions, 13.5% overclicked on 1, 9.5% overclicked on 2, and 0.8% overclicked on 3 of them. The cut score that is closest to 5% is 3, and that fails about 0.8% of people. So we could change the cut score to 2, but that fails about 10% of people, and it feels a bit unfair. So for now, I'm just going to leave that cut score at 3. As I mentioned before, remember, we are seeking multiple instances of strange behaviors, not just a single person making an accidental mistake on one of the questions. So now everyone is scored on every data quality question. In this case, we see the first person failed the red herring measure, but nothing else. The second person looks like a satisficer because they tried to answer as quickly as possible. And what that means is they got caught on 5 measures. The third person looks like an incentive getter because they chose as many answers as possible. So as you can see here, quite clearly, we're not worried about someone who made 1 or 2 mistakes on 1 or 2 questions. That's not the problem. Real people do this all the time. We are worried about people who make mistakes all over the place. So as you see here, once we've got a tally of fails for every single person, we reach the last step of the process. This is where we decide which individual questionnaires to remove from our dataset. So all we have to do here is calculate a frequency distribution of all of the total data quality scores. And you'll get something like this. So this is from a survey that I did recently. Clearly, people who made 4 or more errors are the problem. It took me about half a second to decide to cut those records from my dataset. But I have a standard rule that I always cut 5% of people from my dataset. So in this case, that meant moving the cut score 1 step lower. So I decided that any questionnaire with 3 or more errors or points, flags, would be cut. This meant that about 4.1% of records were dropped. I am positive that some of these people were good, honest people trying to answer the questionnaire as good as they possibly could. Maybe some of them had trouble reading my questions, or maybe their English wasn't their first language, and that is an unfortunate consequence. However, we know for sure that some of these people were simply not answering the survey with good intentions. It is hard to make 8 mistakes on this survey and still be a good, honest person. So let me close with just a few thoughts. Even though it's possible, don't try to cram a lot of measures into 1 question. There are several measures that could work well together, but the problem is we could easily fail people because of their answers to 1 single question, and that's just not fair. We need to spread the data quality measures throughout the survey from the beginning, the middle, and the end. And most importantly, we absolutely must remember that people are not robots. People make mistakes. You make mistakes. It's okay for people to make mistakes on surveys. However, it is not okay for people to make lots of mistakes on surveys. So this brings me to the end of my presentation. If you have any questions, you can either type them in the box or you can email them to me at the email address you see on your screen or the Twitter address you see on the screen, and I'll reply to you as you wish. This presentation will be available as a recording within the next couple of days, and you will get an email with a link to that information. Right, let me just have a quick peek here. I think we're mostly at the end of our time anyway, so getting a few questions coming in. Someone says, thank you. You're very welcome. Let's see. Do you clean it, e.g. the constant sum? When it comes to the constant sum question, I guess there's 2 parts to it. The first part is, are they able to make sure the numbers add up together, add up, for example, to 100%? So if they are not able to do that, that of course means that there is a flag, a point assigned to that data quality measure. If for some reason that is the only point they get in the entire survey, they probably will not count as the worst 5% of people, and they will probably stay in the survey data. So as you can see, their data, their answer to that specific question, won't add up to 100%. This is, I wouldn't say it's rare, but in most cases, it's usually adding up to something like 98 or 99, where the question isn't truly affected by the answer being imperfect. In those cases, I really don't touch the data. I let it be as it is. In other cases where they're really completely incapable of making the data add up to 100%, that would be a case-by-case basis. I may completely ignore the responses to that question. I'll look at the rest of their data to see if there's some oddities about the whole answer, but it really is a case-by-case consideration. Another question, do you still count failed respondents in the overall response rate? Absolutely, yes. If they did the task that was assigned to them, which was either finish the screener or finish right to the very end of the survey, I will count them as officially completed. When it comes to a client, however, I will tell them this specific number of people were removed from the data set because of data quality concerns, and they would be able to see the issues there. Another question, are you familiar with any web survey programs that automatically slow down the survey for speeders? I have heard of these kinds of things. They're done in a few different ways. Some people will deliberately make respondents do every question on a page-by-page basis. They will not join together 2 or 3 questions on the same page. And for some of those people, that is the exact reason. By making them go 1 question at a time, that's their attempt to slow them down. I have also seen some surveys where they will specifically say, it seems like you didn't take a long time to answer that question. Would you like to reconsider your answer? So they will outright tell people to slow down and take their time. I don't have personal experience with that, so I can't comment on whether it works or whether it makes people give a unconsidered response, wait 3 seconds, and then click. But that would be a fun piece of research to do. I'm just checking the time here. I think we are at the end of our time. So what I'm going to do, if there are any other questions, absolutely email me, tweet me, whatever suits your preference, and I will be in touch with you. So thank you for taking the time to join me today. I hope you learned a few tidbits. And feel free to join us again in our upcoming survey and sampling webinars. You can find them on the resource page of the Peanut Labs website. Until then, may your respondents be fully engaged and your data quality perfect. Cheers, everyone.